Today, we're looking at a new kind of threat, and it's not about a single brilliant hack. Instead, it's the story of how a series of small, seemingly unrelated flaws, some even dismissed as infeasible to exploit, can be strung together over time. It's about how these tiny cracks can create a catastrophic failure in a developer ecosystem we're all meant to trust. This single sentence from a vulnerability report just says it all, doesn't it? It perfectly captures the severity of what we're about to explore. It's not just about one bug, it's about the entire foundation of trust just crumbling. So let's trace exactly how that happens. We're going to follow the logical path of this attack, just like a line of falling dominoes. We'll see how attackers think differently. They're not just looking at a single snapshot in time. They're watching the whole movie. They connect these vulnerabilities in a sequence that defenders, who are often looking at each problem in isolation, can totally miss. We'll start with that foundation of trust and end with a complete systemic failure. Right? So modern software isn't built in a vacuum. We all know that. It's built on this whole ecosystem of tools that developers are, frankly, conditioned to trust, especially when they come from a huge provider like Google. And this trust, well, it's the very bedrock of modern development. All these tools are designed to work together, like a really complex machine with all these perfectly interlocking gears. It creates this powerful, seamless workflow. But what happens when an attacker finds a way to poison just one of those gears? Well, the very thing that makes the system so powerful, its interconnectedness, suddenly becomes its greatest source of risk. So the first domino doesn't fall with some crazy complex hack. No, it starts by turning a platform's normal everyday features into an actual weapon. Let's see how an attacker can so cleverly abuse the intended workflow. I want you to put yourself in the developer's shoes for a second. You're on a trusted Google site. You're trying out a cool new AI tool. Copying and pasting a setup command from the screen, that is a daily, totally routine action. There's no obvious trick here, and that's the point. The platform's normal intended workflow becomes the delivery mechanism for the attack. Now, what's so wild here is just how innocent this command looks. It's basically telling the computer to do two things. First, use a tool called curl to download a script from a web address, and then immediately run that script. This is such a common way to install software, which is exactly why it just slides right past our natural defenses. But okay, what if the attacker doesn't even need you to run a command? What if they could compromise your machine silently, in the background, just by getting you to open a project folder? Yeah, this is where things get really, really clever. This is where the trust a developer has in their tools gets exploited in the most dangerous way possible. A zero-interaction attack means you can get compromised without doing anything wrong. You don't have to click a bad link, you don't have to run a suspicious file. The attack just happens, silently, in the background, triggered by a totally normal action like opening a project to look at some code. Let that sink in for a second. The developer has done absolutely nothing more than open a folder to inspect some code. But the tool, the one designed to help them, has this fatal flaw. It blindly trusts configuration files it finds inside the project. And that blind trust is all an attacker needs to silently compromise their machine. And this just illustrates the deception so perfectly. The only thing the user might see is some tiny, ignorable error that looks like a network hiccup. But in the background, a catastrophic security breach has just occurred. It's completely invisible. Now, getting that foothold on the machine, that's just the beginning. The real prize, the ultimate goal for the attacker, is to steal the keys to the kingdom, the user's entire digital identity. So think of this token as a master key. Instead of using your password every single time, an application uses this special, long-lived token to prove it's allowed to access your account. If an attacker gets their hands on this key, they can get into your account pretty much indefinitely, and they never need your password. It's one of the most sensitive things on a developer's machine, period. So where was this master key hidden? Well, the security reports found it stored in a simple, unencrypted text file right in the user's home directory. This is the digital equivalent of leaving your house key under the doormat. It's such a simple mistake, but one with absolutely devastating consequences. And to make it even worse, that file was saved with insecure permissions. So instead of being locked in a private safe, it was like a document left on a table in a public library. This meant that any program running on the computer could just read it. Once the attacker got that initial foothold, all they had to do was open the file and walk away with the keys. And just like that, they've completely bypassed protections like multi-factor authentication. All right, so now the attacker has full control of a trusted employee's Google account. Their focus can now shift from just one individual to the entire organization. This is such a classic confused deputy attack, but with a terrifying modern AI twist. The attacker uses the compromised account to share a poisoned document. A colleague, trusting the source, asks the AI to help with it. But the AI gets tricked. It becomes the confused deputy. It starts obeying the attacker's hidden command instead of the colleague's and begins leaking confidential data. The AI itself becomes the insider threat. And here it is, the game end. The attacker can now use that stolen cloud identity to turn the company's own trusted infrastructure into a launchpad for more attacks. Attacks against its own employees, its own customers, making them nearly impossible for security systems to detect. So as you can see, this was never about a single bug. It was a chain reaction. It was a cascade, where the failure of one security boundary created the perfect conditions to exploit the next. It was a whole series of seemingly unrelated issues that, when combined, spelled disaster. When you lay it all out like this, the chain reaction becomes crystal clear. Every single one of these vulnerabilities may be considered minor or even infeasible on its own, became a critical stepping stone for the next. The weaponized workflow led to code execution, which exploited the insecure credentials, which led to full account takeover. It is a perfect, chilling illustration of how separate, small failures can cascade into a total systemic collapse. This entire chain of events really forces us to rethink the implicit trust we place in our tools every day. It shows that in our complex, interconnected world, security isn't just about fixing individual bugs anymore. It's about understanding how those bugs might connect over time to tell a much more dangerous story. Thanks for watching.